We're on the top of page 2 in our 6.1 notes. We were just talking about even and odd indices. Remember, indices is the plural of index. So when the index is even, we were saying two things. One, the number underneath has to be positive. I don't know how to do the square root of a negative, or the fourth root of a negative, or the sixth root of a negative using the real number system. So the number underneath, which we call the radicand, must be positive, which is that, and the answer must be positive because we call it the principal square root or principal fourth root, which means positive. But then it's a game changer when the index is odd. If the index is odd and I have a negative number underneath, the answer is negative. If the index is odd and I have a positive answer underneath, the answer is positive. So negatives are allowed under an odd index, and it makes sense why, because negative 2 times negative 2 times negative 2 is negative 8. But negative 2 times negative 2 does not give me negative 4. I can't get a negative number when I only multiply it twice or 4 times. Because remember, anytime we raise a number to an even power, it's always positive. But when we raise a number to an odd power, so that'll always be positive if that's even. But if I raise a number to an odd power, I can get a negative number. So that's why it's okay with an odd index to get a negative answer. But it's not okay with an even index. An even index must always give me a positive number because every single time you square a number, it is positive. And then any root of 0, like we said, is 0, just like any root of 1 is also 1. And then I circled the powers that you should be able to recognize by sight. You will save yourself so much time by memorizing those. You won't have to always just keep picking up the calculator. So that would be a good thing to make sure you do. Okay, so I'm going to show you how to do these by hand, and I'm also going to show you how to do them by calculator. So this one you should be able to do by hand. It's in the list above that I told you to memorize. So we said 4 cubed is 64 in that list, which would be right there. So 4 cubed is 64. So with that knowledge, the cube root of negative 64, that means what number times itself 3 times will give me negative 64, and that one would be negative 4. Remember, it's okay to have a negative number under an odd index because negative 4 times negative 4 times negative 4 is negative 64. Fourth root 256. So that one, maybe you know it, maybe you don't, but that's kind of a hard one. So let's learn how to do this on the calculator. And this is a little tricky. It might be something you want to write down just so you remember it. So when the index is not 2, you have to tell the calculator what the index is. So this is a fourth root. So I first have to tell the calculator, oh, by the way, I'm doing a fourth root. And then instead of using the square root key, you have to use this xth root. So you'd hit second caret. And so this is your way of telling the calculator, make that x 4. So the fourth root of 256, there's no parentheses, so don't close them, is 4. So 4 times 4 is 16, times 4 is 64, times 4 is 256. And we could have also done this one if you want to practice on that. So first we have to tell the calculator it's an index of 3. So we do 3. Then we do second caret. And this tells the calculator x is 3. And then we do negative 64, enter, negative 4. Okay. So you might want to write that down, the keystrokes. So 3, and then second caret, negative 64, just so you remember the order. Okay, this one we should be able to do by hand. I think we have this one under control. So remember how I said when it's a fraction, divide it into 2. So it's the cube root of negative 1 over the cube root of 8. So cube root of negative 1 times negative 1 times negative 1 is negative 1. And 2 times 2 times 2 is 8. So remember when I said if you have an odd index, if there's a negative underneath, your answer will also be negative. And you can do that one on the calculator just like we did these. Just remember to use the fraction key. I'll show that one more time. So we do first tell the calculator it's a cube root. So we do 3, and then we do second caret. And now the calculator knows we want it to be cube root, and we do negative 1 fraction bar 8. Hit enter. There's our answer. And 4th root of 81, that's one of the 4th roots I told you that you should know. So if you look above, 3 to the 4th is 81. So what am I going to write for that? Can I write negative 3? So if I write negative 3, that means negative 3 times negative 3 times negative 3 times negative 3 gives me 81. Is that a negative 81? Is that a true statement? No, it's not. 1, 2, 3, 4 negatives give me positive 81. This is non-real. And the reason, even index. Remember above it says an even index, a has to be greater than 0. I don't know how to do the square root or the 4th root of a negative number in the real number system. In the imaginary numbers, we'll learn about it later, but in the real number system, I don't know how to do it. So that's why we write non-real, because no real number times itself 4 times will give me a negative answer. It will always give me a positive answer. Any number times itself 2 times, any number times itself 4 times. But there is a number times itself 3 times that can give me a negative. So that's why odd indices, you can write the answer, because a number times itself 3 times can give me a negative. But a number times itself 4 times can never give me a negative. An even number of negatives is always a positive answer. Okay, let's go ahead and go to this next section. So now it gets a little tougher for students, because now we're going to involve letters, so you can't just pick up your calculator and find the answer. Now you have to have it memorized that anytime you do an even index, the answer is always positive. Anytime you do an odd index, the answer is positive or negative depending on what A is. So every single time we do an even index, the answer is positive. An absolute value A means it's positive. Because when you take the absolute value of something, do you remember that it makes it positive? But an odd index, we saw above, an odd index, we can get a negative number, no problem. But an even index, the answer's always positive. So when it's a number, it's easy to write positive number. But what if it's an A? So that's why we need to use absolute value anytime we're doing the even root of a variable. So let's see how that works. So on cube root, remember the answer is whatever sign is underneath. So if negative 3y is underneath, it's going to be negative 3y. So 3 divided by 3 is 3y to the first, and an odd index gives me a negative number if there's a negative underneath. So no absolute value bars needed. But 4 divided by 4 is negative 3 to the first. Because this is even, I need a positive answer. So I need to put negative 3 in absolute value, as the box says above. If the index is even, take the absolute value of the radicand. So what's the absolute value of negative 3? Positive 3. So even indices have to have absolute value. Odd indices do not, because an odd index can get a negative answer, which we saw up here. But an even index, I can never get a negative answer. It will always be positive. Even index, always positive. Odd index, sometimes it's negative. If this is negative, if that had been positive 64, it would have been positive. So this is kind of confusing for students, so you're really going to have to look at these examples. So odd index, no absolute value needed. Even index, I have to take the absolute value. So even index, I have to take the absolute value. The absolute value of negative 2 is 2. I don't know how to do the absolute value of x, so I just have to leave it in the symbols. So the absolute value of negative 2. So think of this as this problem. When I explain it like this in class, and the students get it better. So the absolute value of negative 2 is 2. I don't know what the absolute value of x is, so I have to leave it in absolute value signs. Why did it need absolute value? Because my index is even. Index is even, absolute value. Index is odd, no absolute value. And these just undo each other, cube and cube root, 4 and 4th root, because they're opposites. So that's why those are going away. So same thing here. Even index, it must go in absolute value. So remember what I said, think of it like this. So the absolute value of negative 2 is 2. But isn't x squared already positive? Anytime you square a number, it's always positive. So it can come out too. So this is why it's so tricky for students, because every single scenario you need to think about. X to the first could be positive or negative. That's why we had to leave it in absolute value. But x squared's always positive. So why would we need it in absolute value? We don't. And the answer does have to be completely simplified in order to get it correct. So the absolute value of negative 2 is 2. The absolute value of x squared is x squared because it's already positive, so absolute value signs are not needed. Okay, let's go to the next page and practice some of these. So how about we do the first 3 and then you do the next 3? Sounds like a plan, huh? So first thing I do is I look at the index. The index is odd, and I tell myself no absolute value needed. So the 5s undo each other. Raising something to the 5th power and then taking the 5th root, they undo each other. So my answer is just x plus 8. No absolute value needed because my index was odd. I only use absolute value when the index is even. So here we have a negative out in front. And then I say to myself, do I need absolute